13.4 billion years ago, light set off on a journey across the universe, carrying with it a groundbreaking secret: the signature of oxygen, detected in the most distant galaxy ever observed. This galaxy, known as Jade's GS-Z14-0, is located so far away that its light took 13.4 billion years to reach us. It formed just 300 million years after the Big Bang, a time when the cosmos was much younger, and finding oxygen this early is nothing short of astonishing. The discovery came from the Atacama Large Millimeter-Submillimeter Array, ALMA, located high in the Chilean desert. ALMA picked up the faint but clear signal of oxygen, specifically the 88-micron fine structure line. This line is a reliable tracer, meaning it can travel vast distances through space without being blocked by dust, making it perfect for studying galaxies from the early universe. Oxygen is not a primordial element. It is created in the cores of massive stars and spread across space when those stars explode. Finding it here means Jade's GS-Z14-0 must have already experienced at least 2 generations of star formation. In a fraction of the time that was previously thought possible, astronomers measured the galaxy's distance with incredible precision, narrowing the margin of error to just 0.005%. The oxygen detected suggests that the galaxy's metallicity, the amount of heavy elements compared to hydrogen, is about 1/5 that of our Sun. But what's even more surprising is that no significant dust was found in the galaxy, which means its dust-to-stellar mass ratio is incredibly low, less than 0.2%. This points to a very early stage of galaxy development. The ionized gas in the galaxy is moving at around 70 kilometers per second, indicating that the galaxy has a mass of about 1 billion times that of our Sun and is likely surrounded by a large dark matter halo. This challenges our previous models, which assumed early galaxies would form gradually, starting small and metal-poor. Jade's GS-Z14-0, however, seems to have matured far more quickly, possibly due to intense bursts of star formation or unusually massive stars that produced oxygen rapidly. Adding to the excitement, the James Webb Space Telescope, JWST, also picked up some intriguing data. It detected an excess at 7.7 microns, which is consistent with oxygen and hydrogen emission lines. More significantly, about 10% of the galaxy's ionizing radiation appears to be leaking into intergalactic space. This suggests that Jade's GS-Z14-0 could have contributed to the early reionization of the universe, when the first galaxies started to light up the cosmos and transform it from an opaque fog to a transparent expanse of stars. This discovery forces astronomers to rethink how galaxies form. Models that predict a gradual, slow buildup of heavy elements in galaxies may need to be updated. Jade's GS-Z14-0 suggests that the universe may have learned to evolve faster than we thought. Perhaps, in some cases, early galaxies formed and grew rapidly, driven by powerful star formation bursts or by denser, gas-rich halos that collapsed earlier than previously assumed. And this is just the beginning. Future observations with JWST aim to detect even more elements like carbon and nitrogen in Jade's GS-Z14-0. ALMA will continue to scan the universe, searching for more early galaxies that might have followed a similar fast-track path. In the coming years, the extremely large telescope will be able to resolve star-forming clumps just hundreds of light-years across, revealing the ongoing processes inside these ancient systems. Whether Jade's GS-Z14-0 is a rare anomaly or one of many early galaxies with a rapid chemical evolution, its discovery is a game-changer. It shows that the universe may have been much more dynamic and fast-paced in its infancy than we ever imagined. With every new discovery, our understanding of the early cosmos becomes more flexible and surprising, reminding us that the universe's story is still being written, and it's filled with far more twists and turns than we ever thought possible.